Hello and welcome back to the tutorials about the function blocks of the Flexisoft Motion Control Module Mach1. This video deals with the converter function block UIA to Boolean converter. This function block is important for routing signals from the Mach to the CPU because the function blocks in the Mach1 logic are able to process integer values. Integer values can't route between Mach and CPU, so we have to convert an integer to Boolean. Let's switch to the Mach1 logic to focus on the relevant in and outputs. But first we have to navigate to the converter function blocks and place the UIA to Boolean converter in the configuration area. The only input of the function block is input 1. The number of outputs can be set by opening the configuration menu. Here you can define up to 8 outputs. This allows it to convert integer values up to 255 into Boolean. In our example, 3 outputs are sufficient. Now we connect the input 1 to the output position status ID of the position monitor function block. This output delivers the position status ID of the current position range in which the drive is operating. These speed IDs are integer values and the UIA to Boolean converter translate them to Boolean values at its outputs. Just remember the last tutorial where we have defined 6 fields which all have the same size of 60 degrees. As you already know, these fields are assigned to position IDs which are output at the position status ID as in this table. The position status ID 6 is output when the drive is operating in position range 6. After that, the position ID is delivered to the input of the UIA to Boolean converter. Now the integer value of the position ID is converted into Boolean. This means that output 3 and 2 are going high and output 1 is going low. That's because the Boolean values 1, 1, 0 corresponds to the integer value 6. The same principle also applies for the other position ranges. Now I want to show you how to route these signals to the CPU logic by the backplane bus. In this context, we switch in the left sidebar from function block to outputs. Here we find in the register CPU3 the output bits. With these bits we can route the signals from the Mach to the CPU. Now I just select the first 3 outputs and place them behind the UIA to Boolean converter. Then I connect each bit to an output. Now I show you where to find these bits in the CPU logic and how to use them. If you now switch the left sidebar from outputs to inputs, you find in the register Mach1 the signals from the Mach1 logic. These bits now are used as input bits. Therefore, we select these bits and connect them to the routing function block. After that, we have to switch to the tab Outputs and select the 3 lamps from the XTIO module and connect them to the outputs of the routing function block. Now we have successfully integrated the output bits with the lamps. For this reason, the lamps are switched on and off depending on the current position ranges. I want to show you this in a short example. We assume that the current position which is checked by the position cross-check is between 240 and 300 degrees. In this case, the speed ID 5 is generated in the function block position monitor and transferred by the output position status ID to the input of the UIA to Boolean converter. The UIA to Boolean converter then translates the integer value of the speed ID to Boolean. With the output bits, the converter signals are routed by the backplane bus to the CPU logic. Now, the lamps 1 and 3 are switched on because they represent position range 5. That's it about the converter function block UIA to Boolean converter. Now you've got to know how to combine it to other function blocks. Also, you learned how to route the signals from the Mach1 logic to the CPU logic. In the next tutorial we focused on the function block SafeStop.